Okay, you guys, how did you do on this? So when I left you, you guys were going to work across, starting I think at CW, and determine if you could cross out or exclude any further antibodies from this patient, Mrs. A. Johnson. So let's see if you guys have got the same thing that I've got. So we started out with looking at the D, and we weren't able to put any slashes across it. And then for C and E, we had one slash because we were able to find one cell for each. A panel cell that was positive, yet it did not react. And then we were able to double cross out little c, little e, and little f. And then I found that I could not cross out CW or V. There was no positive cells for CW and V that did not react, so I can't exclude them. And then I went on to Kel. Now, often students will not have crossed out Kel because they're looking for a homozygous Kel cell that did not react. And that's true. In this case, we've got a heterozygous Kel cell that did not react and another heterozygous Kel cell that did not react. But if you look at the rules on page 9, Kel is not listed as one of the antibodies in 3 Roman numeral 1 that shows dosage. So 3 Roman numeral 2 applies to Kel. And for these antibodies, they can be excluded based on non-reactivity of the patient's plasma with at minimum 2 heterozygous cells. So indeed, I've got 2 heterozygous cells. So that's why I have a slash and then another slash on big K. Little k is easy to exclude because 100% of people have the little k antigen. And so on this panel of donor panel cells, everybody has the little k antigen. So it was pretty easy to find a homozygous Solano or little k cell, another one, and then I really stopped looking because I've got my 2 slashes across little k. You'll notice that KPA is not crossed out, but KPB was easy to cross out. JSA is not crossed out, but JSB was easy to cross out. And then in this section here, you have to be really careful because it's a little bit harder to see. So make sure that you can see your slashes. So I've got M crossed out, N, big S, little s, FYA, and FYB. Over here in the kids, I've got them both crossed out. I've got both Lewis's crossed out. And Lutheran A, I was only able to find one cell, Lutheran A positive cell that did not react. So I only have one slash for that. Lutheran B, I was able to find many positive cells that did not react, so it's crossed out. P1 is crossed out and XGA is crossed out. They stand on their own. So that's what I'm left with. And then what I do, actually I'll stop there and say if this is not what you got as far as crossing out, then what I'd like you to do is send me an email and let me know what we have that's different, because there's really no point in continuing unless we've got this part right. So what I do now is I take a look at what I've done and I do some what I call marking up. And this is just a way for me to denote things that I'm really not going to worry about further, and then think about things that I am going to be concerned about. So I've got a D that is not crossed out at all. And so that's my biggest clue here, is that does my patient's plasma contain an anti-D? Or perhaps, does my patient's plasma contain an anti-C or an anti-E? Because I only have one slash on those. So those are still in the running. The ones that have 2 slashes have been excluded. So we're saying that the patient's plasma does not contain an anti-little c, anti-little e, little f, k, Solano, etc., etc. CW is an LPA and so is V. So on top of those, I just write LPA, and I'll explain why I'm doing that in a minute. So KPA is an LPA as well, and JSA is an LPA. And if you need a list of the low prevalence antigens. That's what LPA stands for. You can take a look at page 9 at the bottom of the page there, and you can see them listed. I can tell they're LPAs as well when I look at a panel because they're almost all negative underneath the column. LPA stands for low prevalence antigen. So these antigens are not present on the majority of our population. The rest of the page here, actually Lutheran A is an LPA. And that's it. Now the reason I've done that is because antibodies to low prevalence antigens will be very difficult to cross out because we don't find the antigens represented on the panel cells. So we do not go to extra work to try to find a panel cell that has these low prevalence antigens on it because it's very difficult to find. So this information is at the bottom of page 9. Now, if I had some sort of reason to believe that an antibody to a low prevalence antigen might be present, and I'll explain that in a minute, then I would pursue it. But otherwise, we don't worry further about low prevalence, about antibodies against these low prevalence antigens. It doesn't mean I'm excluding them. It just means that I'm not going to worry about them further. Very, very uncommon to find an antibody against a low prevalence antigen in our patients. That's explained in the module, so I'll talk about that again a little bit later as well. So what have I got left here? Really what I've got left is I've got a D with no slashes, a C with 1, and a big E with 1. And everything else is either crossed out or it's a low prevalence antigen. So is the antibody in my patient's plasma, is it a big D, a big C, or a big E? This is the decision that I need to make at this point in time. So if you turn to page 10 in the module, you'll notice that step 4 is pattern recognition. So what I mean by that is the pattern that we're seeing of the patient's plasma with the various panel cells is negative, plus, 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 negative, 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 plus, plus. Does this pattern match D, C, or E? No, we don't need to look at anything else. It's crossed out. So this pattern, actually I'm going to fold my paper just because I do have limited, you guys don't do this. I just have limited space because of my view here on my video camera. So I'm just going to fold it over so that it's right beside the D, C, and the E. So, and I can get it in my screen here. So looking at D, C, and E, I'm looking for negative. Okay, well, sure enough, under the D, panel cell 1 is negative for D or E. And then I'm looking for 3 positives. And then I'm looking for negative, 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 plus, plus. Can you see that this pattern exactly matches what we would expect if the patient's plasma contained an anti-D? Negative, plus, 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 a bunch of negatives, plus, plus. Negative, plus, 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 a bunch of negatives, plus, plus. Does that make sense, you guys? Pattern recognition? So notice all the work that we did before we got to the point where we were going, oh, look at that. The pattern matches an anti-D. It doesn't exactly match the pattern we would expect if the plasma contained an anti-big C. If the patient's plasma contained an anti-big C, we would actually expect a positive reaction with the first cell, positive with second and third, which we did get. We would expect negative with cell 4, and then negative for cells 5 through 9, negative for cell 10, and we would expect positive. So no, the pattern for C and E don't quite match. So I really feel that I have an anti-D present. So I'm going to stick an arrow up on top of anti-D because that's the antibody that I think I have. Now our next step is step 5 on page 10. And this says set up exclusion cells if required. Well, an exclusion cell is just more panel cells. We ran 11 panel cells, and yet, even with running 11 panel cells, we were not able to completely exclude that the patient's plasma contains anti-big C and anti-big E. So we're going to need to set up more panel cells. Now you're going to have to find a different panel. We've already set up this whole panel and there's no point in setting it up again. So we need to find another panel. So you can go and find in your lab, hopefully there is you guys purchase a different panel. So for example, here's panel 31874. The panel that we originally had on Mrs. Johnson was 1225. Looking at this panel, is there a cell on here that would help us determine that the patient's plasma contains only an anti-D and not an anti-big C or an anti-big E? And you guys have a copy of this panel at some point in time in the module. I think it's scan 178. We used it for another activity. My thought process is I want to set up another cell that is positive for big C and negative for D. The reason I want it to be negative for D is because I feel that my patient's plasma contains an anti-big D. So there's no point in setting up another D positive cell. I've got lots of D positive cells that reacted. I want to set up a D negative cell that's positive for C. And if it doesn't react, then I'll be putting a second slash on my C. And the same thing for big E. I want to find a D negative cell that's positive for big E. And if it does not react, when I react that cell with my patient's plasma, with PEG added and taken through IAT, then I'm going to put my second slash on big E. So the two cells on this panel that I really quite like are cells 5 and 6. Cell 5 is positive for C, and cell 6 is positive for E. Now they are heterozygous cells, so that's too bad because I would actually prefer to use to have a cell that is homozygous for big C and react it with my patient's plasma. But I don't see that available to me. I have another negative D cell here, but again, it's heterozygous for C. And this is the only D negative cell that's positive for E. So I'm going to set up cells 5 and 6. And what I mean by that is I'm going to take 2 test tubes, label them panel 5, panel 6, and my patient's accession number. 2 drops of patient's plasma, 1 drop of cell 5 into one tube, 1 drop of cell 6 into the other, 2 drops of PEG, and into the incubator and taken through the IAT procedure. If these tubes do not react, then I have my second slash for big C and big E. Now, if you recall in the first panel, we did obtain this 1 slash for big C, and it was because we had a C positive cell that did not react, and it was hetero, and my E positive cell that did not react, it was hetero. So I have not achieved my rule of finding homozygous cells to help me do my excluding. Luckily, there is a caveat to the rules, and that's over on page 10 in your module. So if you look on page 10, at the top of the page, Roman numeral number 3, there's a note. When an anti-D is identified, the big C and big E can be eliminated using 2 heterozygous cells. Now that is actually not just a SAIT rule. That's a very common rule used in most labs, as it's really quite difficult to find a D negative cell that is homozygous positive for big C and or big E. So take a look at a panel sheet to see what I mean by that. It's just very difficult to find. So luckily we have this little caveat to the rule, and the additional 2 cells that I would set up would be from this panel, cells 5 and 6. If when I set them up they did not react, I would go back to my original panel and put a slash across big C and big E. And I would staple this panel sheet completed, filled out completely with the patient's demographics and everything, the results listed, and I would staple it to this panel sheet because this is all the work that's been done on Mrs. Johnson. So I feel pretty happy that my patient's plasma only contains an anti-big D. And step number 6 on page 10 says to ensure there is adequate evidence to prove the suspected antibodies. And we must satisfy a rule that we call the 3-3 rule. So we need to have at least 3 D positive cells that did react and at least 3 D negative cells that did not react. And we have at least that because we've got 1, 2, 3, 4, 5 D positive cells that did react and 1, 2, 3, 4, 5, 6 D negative cells that did not react. And really, I can also count the panel cells that did and did not react as well. So I've got at least 3 panel cells that react, D positive cells that reacted, and at least 3 D negative cells that did not react. And that will give me actually 95% confidence. If you want me to do the math for you, maybe just send me an email and I'll send you the math. Okay, most students don't really care. They just trust me on that, but no problem. We can do some math if you like. Step number 7 on page 10. The next 2 things that we need to do is we need to antigen type the patient. Well, antigen type them for the antigen corresponding to the antibody. So what is the D type on this patient? Well, that's usually pretty easy to find because the patient has been ABO RH typed and the patient is A negative. So the patient is negative for the D antigen and they have produced an anti-D antibody, which is possible. People make antibodies against antigens they do not have and have possibly been exposed through pregnancy and transfusion. So it's a check on our antibody ID. We should find that if the patient's autocontrol is negative, that the patient's antigen type will be negative for the antibody that they have produced. Please let me know if that doesn't make sense to you. In addition, on page 10, we're going to antigen type donor units, which is really important. We don't need to give Mrs. Johnson donor units that have the D antigen. So we will go to our fridge actually. And it makes it pretty easy when somebody has an anti-D because we'll just choose some A negative donor units for Mrs. Johnson. And we won't actually need to D-type the donor units because that's already been done once by Canadian Blood Services and then once again by the hospital site that received the blood units. They would have D-typed them a second time. So they're confirmed to be D negative. The last step we have is over on page 11, and the last thing that we need to do is do an IAT cross-match of the patient with some donor units. And whenever we have to do an IAT cross-match, we would do that right away, unless this was a pre-op patient, so their surgery booked at some point in the future. We would wait to the day before their surgery to do the cross-match. But this lady's in. She's an inpatient. It doesn't mention that she's pre-op. She's going for a C-section, which I realize is a surgery, but she's an inpatient. If this was a pre-op collection, we would see on her type-in screen that it came down with a surgical date shown and that the patient had answered these 2 questions. Have you been pregnant or transfused in the last 3 months? Now, this patient has obviously been pregnant, so she doesn't qualify for the extended timeline on a pre-op type-in screen. So her type-in screen outdates in 96 hours from collection. So we can get the units of blood matched for her, and that way when they call, they can have the units up and running into her very, very quickly. We don't need to be starting an IAT cross-match, which takes about 20 minutes. When they call, we want them to call and we have the blood ready. So we will do the IAT cross-match right away on Mrs. Johnson and find 2 D negative units that are IAT cross-matched for her right away. Get those units tagged and get them back on the shelf, and they'll await a phone call from the patient care unit to send up these particular units for Mrs. Johnson. So that's the antibody ID on Mrs. Johnson. There is another antibody ID to do right on the following pages. It's on Mr. Alvarez, I'm pretty sure is the guy's name. So this antibody is found on page 15 of your module. And again, I believe there is a bigger, clearer version of that panel sheet on Brightspace. In addition, if you look over onto page 16, it says that you can complete antibody panels A through E. So we've got a bunch more panels there that you can do if you need extra practice. And I would suggest that you do panels A through E. Some of these are a little bit harder because they contain more than one antibody, but that's really good practice for you. But if you are struggling with an antibody panel that only contains one antibody, like Mrs. Johnson or Mr. Alvarez, then don't continue on to a harder antibody panel. Get in contact with me and we can see if we can work out your problems. So in addition to this video, there is an antibody ID tutorial, which is PowerPoint format, and it's on Brightspace. So take a look, decide what works for you, and make sure you let me know if you have any questions.